Hello, my name is Ion, and today I'm going to be walking you through the introductions of chemistry. The first thing we have here is to understand the Bohr model, or how electrons work in an atom. I will be making another video on the atom itself and the different parts of it, but right now we are going to focus on the chemical aspect of atoms. In order to understand that, we have to look at the base model, which is basically illustrated through the Bohr model. So in here you have the main nucleus inside, and you have the electrons of the atoms. Now usually it orbits in a cloud-like formation because it orbits at the speed of light, but the Bohr model suggests a more precise way to measure how it moves and how it interacts with other elements. What we're going to do is we're going to look at one type of bonding, which is basically when two types of elements bond with each other and they form completely different type of substance, if you will. Like NaCl, for example, which is sodium and chlorine, they both bond together and they form table salt, which is a completely different substance. Sodium by itself is extremely dangerous, but chlorine is also on the more dangerous side. But they both form table salt, which is commonly used in cooking with humans, if you will. I'm going to cut this part a little bit, and then now we're going to talk about ionic bonds. Now this is a simple illustration I have created with you. This is potassium, the Bohr model of potassium, and chlorine. Now chlorine is a nonmetal, while potassium is a metal. Ionic bonds can only be formed with a metal and nonmetals. If it's a nonmetal and a nonmetal, it'll become a covalent bond. In a future video, we will be talking about a covalent bond. Covalent bonds are a little bit more complicated due to polarity, which we will talk about in that video. Right now, forget all of that other stuff and let's just focus on ionic bonds. Ionic bonds are happening between two elements, commonly a metal and a nonmetal. Take this example for example. K is the atomic symbol for potassium, and Cl is the atomic symbol for chlorine. Now, the electrons on the very outside, which is represented with green in this picture, is called valence electrons. These electrons are the outermost electrons. These are used commonly for bonding, especially ionic or covalent bonding. The green represents the valence electrons. Potassium has one valence electron. As you can see here, it is in group 1 potassium, which means it has one valence electron. You have chlorine, which has 7 valence electrons, because you can see chlorine is in the 7th group or column of the periodic tables of elements created by Mendeleev. So what happens is, in this demonstration, this will become KCl, is what it's commonly called. So the potassium will give away one of its electrons to chlorine. Now this is due to electronegativity, which is basically this has more forces that attract this than this, which is basically in simple terms. Nevertheless, this valence electron ends up here, which creates a full shell for both of them. This outermost shell evaporates and it has a complete shell of 8. This also gains an electron, a valence electron, and it becomes 8. This loses one, this gains one. So this will become K minus, and this will become Cl plus, or this will become Cl plus, this will become K minus, because each valence electron has a -1 charge. So the charge of this will be +1 because it loses a valence electron. This will be -1 because it gains a valence electron. They will both achieve their complete shell on the outside, which basically means it has the most number of electrons in the final shell. The final shell will have 8 on the outside, unless it's the first shell, which has only 2. This will gain 8 because it loses 1, and this ring will just disappear basically. And this will move this way, and it'll go over here. One way you can visualize this is as though he has something, and he wants that something. He doesn't like that thing. Let's say, think of it as like a kid, basically. One kid has a present, and this kid doesn't have that present. He wants the present really bad, but this kid doesn't want the present. So if this kid gives that kid a present, he won't have the present, so he's happy. He will have the present, so he's also happy. It's basically how it works in the atomic level. Now you've learned about ionic bonding. The next video will cover covalent bonds. Thank you for watching, and I will see you guys on the next educational video I post. Thank you.